great.
Okay,
Let's
good
go.
deal. Hey, welcome everybody to Tech Talk Tuesday. This is season 3. I have no idea which episode it is, so you have to watch the recording to find out what episode it is. I think this is, I don't know exactly what we're counting. This is our first training Tech Talk of season 3. So Chris and Andy are going to take one live session a month and take a higher level elevated concept, and I'm going to take something that relates to what they're talking about and then bring it into the training realm, and then we'll have some other on-demand topics that you can pick up as well. This month is all about sustainability. So Chris and Andy talked about pumps and managing pumps. Well, we've got something to build on managing pumps. We're going to talk about managing secondary water sources, and we're going to, since this is training, we're going to get into how to set them up and some specifics on that one. So, but I guess I wanted to pause for a second, Tracy, and kind of how do pumps and secondary water sources, I have a couple of thoughts how that ties into sustainability. What do you think? What's your thoughts on that?
Yeah, we see in along the Front Range of Colorado, especially, we see people starting to tie gray water
Hmm.
pipelines in. So they may have some city water, and now they're bringing gray water, that's water that's just refined enough for irrigation but not drinking, into parks on a pipeline, or surface water from ponds, things like that, to get off of that city water and use a more sustainable source of water.
Right, right. Because of course, city water, which is what I use mostly in the West, um, is it's chlorinated, fluoridated, pressurized, and it's pulling from everybody else that needs it. So having another water source that's doesn't come off of that one can make a big difference. So I think that's
Mhm.
a good call. And the we don't have so much in the way of gray water, but we definitely have some recycled or reclaimed water. That's real common out here.
Mhm.
And maybe you're going to get into rain catchments or into desert communities, might get into air conditioner condensation. Now, some of
Yeah.
those are going to be small amounts though, right?
Mhm.
So you need to be able to switch and manage from that as you go through. So, well, let me show you. I've got some information I'm going to show you. So I've got a site we're going to take a look at. So here's my site that we're going to take a look at today. And this site is a city park. And this city park has a 3-inch main line, this light blue line that kind of runs around the park. And there's two water sources right now. There's an 1.5-inch domestic meter that's fed from city water over on this side of the property. And the other side, I've got a 3 horsepower pump. So we have the two water sources feeding the one main line. So let's set up some limits on that one and see what that looks like. So for that, I've got to have base manager. Now, ooh, we could do this at the controller, couldn't we?
Sure. Yeah, we could definitely do it at the
Yeah.
controller if we wanted to.
Yeah. Now, if you want to, right? Of course, I think that base manager is always so much easier. Just as long as you have a method of communication, man, this is going to be quicker, easier, and honestly, I think it's more intuitive. At the controller, you're going to have to make a couple more. You're going to do the exact same steps, but the order might be a little bit different than what we're going to see in
Sure.
base manager. So let me double check, make sure I'm on the right controller. So I'm going to go to the menu and sites and controllers. I'm on my demo 3200. Perfect. That's the controller here in my office. Now we're going to get into flow setup. So it's going to be on the flow setup tab over here. And before we do that, we've got 3 different things on flow setup. We've got water sources, control points, and main lines. So a water source is where we're getting the water from a system. So I've already said a city meter, a pump, a surface water from a lake, a well, a rain catchment. That's your water source. But Tracy, what goes into a control point? So what is it? Do you want to give us a brief definition of a
Sure.
control point?
Sure. So control point, is anytime we're going to take control of a section of main line or monitor a section of main line in a certain way. So whether it's a master valve normally closed or normally open, a flow meter, a pressure sensor, all of those components could be considered a control point.
Right. And the way I have a very similar definition. It's it's a could be a master valve, could be a flow sensor, could be a pressure transducer, could be a pump start relay. Realistically, 3 things. We count them together So 8 control points. So theoretically 24 devices combined
Mhm.
managing your system, but you don't have to have all 3 of those things in that control point. So
Correct.
8 water sources, 8 control points, and then the next one is the main lines. So we can also have up to 8 main lines on our system. So, and each main line, the main line, the control point, the water source, each can have different flow characteristics, and they often do. So setting up those flow characteristics for each of these is going to be really important. So you're going to jump into water sources. Now, I've already got my 2 water sources in here. I've done some of the homework for us to make this a little more streamlined today. So let's open up water source 1. And to make any changes, I got to be in the edit mode. So let's go to edit. Now, this one I've already named the 1.5" domestic meter, right? That's great. So this makes it a lot easier if it's already named. It's enabled by default. That's great. And this is connected to or assigned to control point 1. Now, I have 2 control points on this system, so I need to make sure that I know which one it is, right? So make sure you know which master valve and which flow sensor you're using, because if we're trying to connect to the wrong master valve or opening or closing the wrong master valve, that'll throw things off.
Mhm.
That's about it. That's all I really wanted to just review on this. There's some other things that we can get into, but that's not for today. So let's save that. So we're going to go all the way through water source 1 to go through all the flow characteristics. So the next thing is control points. So let's go to control points and control point 1. We actually have some work to do here. So the control point 1 is named. It's at the 1.5" meter. And control point 1 is there's only one main line. It's connected to a 3-inch class 315 main. That's kind of very specific, isn't it, Tracy?
Yeah. Yeah.
A little different than a 3-inch schedule 40 or a 3-inch polyethylene or 3-inch copper. Each of those have different flow characteristics. Okay, this designation is going to be really important in just a moment. So design flow. Do you know offhand for certain what a 3-inch class main can carry?
Off the top of my head, I don't, but I'm going to guess right around 100 gallons a minute.
Yeah. Well, okay, so here's something. This is a little tricky. Is the 3-inch main, we aren't even on main lines, we're on the control point. So I'm going to pick the limit of the water meter. So let me rephrase the question. How about a 3/4 inch water meter? Or excuse me, inch and a half water meter. Ooh, 1.5" water meter. I had to look that one up because I wasn't sure.
Maybe
It's
40 gallons a minute.
75.
75.
Yeah, 75 GPM. Now, what would be great is there may be a designer in the room that's going to chime in and say, Dan, you're completely inaccurate. And like, oh,
Hmm.
I'm gonna have to, I won't check live, but I'll check after the class if you say I'm wrong. Okay, so 75 GPM. I'm going to pick a high flow limit, and my high flow limit, I'm going to try 20%, but I don't know. What do you feel more comfortable with, Tracy? Do you go 10? Do you have a starting point that you like to use?
Typically about 10% is where I like to
10%.
start.
Okay.
I like to start there, and I like to, this is maybe a little different than what you were planning on talking about here, but when I first set this up and start to do learn flows, I like to have the customer not put the control system in shutdown mode and watch, because their high flow limit may be set inaccurately as
Oh,
we
nice.
see flow so live, right? We're not masking our flow with math. So we may be able to see zones opening and closing, and our high
Nice.
flows may spike a bit higher than we think they would on paper. Hydraulically, valves open and close.
Yeah, that's interesting. I'd never even thought about that. So right now I put in 76 GPM. Well, man, we're going to get alerts all over the place, right? It's 1
Yeah.
GPM above that. So okay, I like your idea of starting at no shutdown and starting at 10%. My homework that I already did, I am looking at 20%. So, but I'd like your advice. So maybe try as Tracy said, and then listen to what I'm saying, and then pick. Ultimately, you got to pick your own. I think that's the big one. Yeah. So 10%, 20%, some range somewhere in there. You need to feel Depends upon you and what you're comfortable with your system. So 20% in this case is 90 GPM. Now, so right now, what happens? Well, two questions. If I'm expecting 75 GPM through there, why would I get 90 or 100 GPM? Most likely a break, right?
Right.
So that would be the most common. Now, assuming it's not a small variation, if it's an enormous variation, well, shutdown then does two things. So what we want to describe what happens when we get in this case, the way I have it set up with a 90 GPM limit and a shutdown, what happens when we exceed 90 GPM for a sustained period of time?
We're going to shut down the master valve.
And we get an alert, right?
Right.
So here we're without the shutdown, I get an alert. With the shutdown, I get shutdown and an alert. So I also like that point, Tracy, of during the trial period is don't shut down and see what happens and kind of get with it. Okay. So 9 times out of 10, once your systems is established, you do want to shut down. I'm going to skip the pressure limits, but we could do something with that. That's not what we're working on today. Here, I'm going to put an unscheduled flow of 15 GPM. And the way I define unscheduled flow is flow the controller doesn't know about. So bleeding a valve, a quick coupler, those are two prime examples of unscheduled flow. Mm-hmm. Okay, so the devices, keeping in mind we're at the control point level right here. So this is master valve, flow sensor, pressure transducer. Let's come down to put the hardware in here. So the flow meter, because I've already named these in the devices column here, this is brilliant, right? I already know which one it is. It's the 1.5-inch flow meter. Done. K value populated. So the K value now is going to translate those pulses into GPM. Mm-hmm. And that comes with our pre-program baseline flow sensor. Now, Tracy, if I didn't have a baseline flow sensor, I got to pull it out and put a new one in because I need to get that. Is that accurate?
Yeah, that's accurate. Yeah, because the controller doesn't know unless it's a baseline sensor what that K value is. So
right. Well,
you would have to go to the manufacturer book and take the specs and find the K
right.
value offset.
So if I added so I guess the takeaway of this, if you add your own flow bicoder because you have an existing flow sensor, you're going to have to put your own K value in. Perfect.
Correct.
Okay. So let's go to the master valve. I've named the master valve. Beautiful. That's easy. And I can select, is it normally open or normally closed? And then the pressure sensor, I have not named my pressure sensor, so I got to go out to the field. I got to look up and see what's in there. So I'm going to wait on the pressure sensor. So we're just going to leave, and maybe you don't have one. Maybe you just have one or none of these devices. So let's see what we've done in here before we leave. We have the device or the association. It's the description. It's connected to 3-inch main. I've got limits and I've got the devices, so we can save this. Now let's go to the main line and set up the mainline limits. Okay, so on my main line, let's go to edit mode. This is the class 315 main. And the design flow for the class 315 main is, oh, I got it. I already wrote it down, is 100 GPM. Oops, 100. And I wanted to show you where I got this information from. So I have a friction loss chart here, and this is in the back of every major manufacturer catalog. Friction loss charts are really valuable tools, right? They tell you a lot of information. What do you recall what kind of info's in here, Tracy?
You get flow and you get feet per second. You get velocity and friction loss across there. So
right, yeah,
pipe size, flow ranges for trying to stay under 5 feet per second.
Right, industry standard is 5 feet per second. So I was able to look at a 3-inch class 315, which is different from 3-inch schedule and different from 3-inch polyethylene, right? All different flow characteristics. Looked it up and said, this can carry 100 GPM. That was a real number, and it's an important number to not guess at. Because I'm going to use managed by flow. Managed by flow then allows me to maximize that 100 GPM. And I'm gonna not go into too much depth. And then the last thing I want to do is put a flow variance limit. So what's a flow variance limit that you like to start with, Tracy?
I like to start high, so I typically start around 30%.
Okay, cool. So 30%, and if I have a mainline break, I probably, or a lateral, a valve that won't close, I probably want to shut down.
Mhm.
I like that. But what if it's 30% less? Well, it's going to shut down too, right?
Mhm.
Well, if it was peak summer, I don't know. I might want to get maybe a valve wasn't opening all the way or a ball valve was. I might like to get some water on and get an alert. Well, I don't have that option here. So what I really like is this advanced flow variance here. And I've already set up some limits on here, and this has different percentages, which is really nice to have a very high range for, I mean, a very high flow percentage on low flows, and then a lesser tolerance on highs. But right here, I can shut down for high flows, shut down an alert for high flows, but not shut down for low flows, but just get an alert. So you
Mhm.
kind of I think you get the best of both worlds with this.
Sure do.
Okay. And then that's all we really need to do. Once we've learned flows, this design flow will populate, and then we can start using managed by flow and other things. Okay. So far we have set up this meter and this mainline limits. We need to bring in this pump station. So that's why I didn't want to get too far off track and go into the pump station. So let's go into the water sources and go to the pump station and go to edit mode. Now, the first water source was already check marked and enabled. So I got to enable this one. And that's all I need to do. Let's save that. And then the control points. Let's go to the control point at the pump station. Now, in this case, depending upon the pump station, we may have a pump start relay or we may have a master valve. Kind of depends, right, on the pump that we're using. Let's go to edit. This is also connected to that main line. And the design flows for this one is a little bit different because this is a bigger pump station. So this pump station can carry 100 GPM. And if we went with 20% or 10%, I could do 120 and I could use my same unscheduled flow. So I'm pretty much doing the same thing that I did before. Here's the devices. I've got them named, so this makes it really easy to name these. There's my K value and the master valve, and can't use my pressure sensors yet. So let's save that. And then the main line, there's only one main line. So what we've done is we've set up flow limits for this 3-inch class 315 main line, flow limits for this meter, and flow limits for this pump. So let's look at something, and I got a question to Tracy, so get ready for it. The domestic meter is set to water source priority 1, and the pump is set to water source priority 1. We've got two water sources. Which water sources used first, or how are those, let me rephrase that. How are those water sources used since they're both priority 1?
So the controller is going to draw from both when they're both priority 1.
Exact same time, right? Well, I don't think we want to do that in this circumstance because we're trying to. I think we'd like to use the pond water because that's going to get off of some of that city water. Now, what you just said though would make sense if I had 2 or 3 water meters on a city that was all domestic and I had to feed all of them at the same time. Then you might want to use them all to feed. Well, let's say I had 3.5-inch meters feeding a 6-inch main.
Mhm.
That might make more sense. So what do you suggest? We make the pump the higher priority? You thinking that?
I would make the pump the higher priority and your city source as the second priority.
Okay, so we're going to leave this at the highest priority right here. And then we're just going to go to the meter, go to edit mode, and we're going to just make this a lower priority. And it doesn't matter if it's 2 or 7, just as long as it's the lowest priority. Okay, so the water meter is the lower priority. Let's look at this again. Higher priority 1, lower priority 2. Okay, the pump. So with the prioritizing water sources, the controller will always use the higher priority first. So if that so if the water source 1, the pump, ever goes offline, it will automatically switch to my 1.5-inch water meter with its lower limits, right? So we had 100 GPM on the pump and only 70 on the meter. Everything's going to step down, especially in that managed by flow. We'll have lower capacity on the entire system.
Yep.
Now, so you're a good real world person on this one, Tracy. Why would my pump what would take my pump offline that I would ever switch to the meter?
You could have a power outage. You could have, maybe you've got some low level lake indication going on that would shut your pump down.
Right.
You need to transfer to that city source, so that you don't draw your lake or your pond down below the amount of water you're supposed to be using.
Yeah, that's exactly right. Okay. So anytime that pump goes offline, automatically, assuming we've got master valves and flow sensors on either side, it's going to automatically switch over to the other water source with its lower limits. And then when the pump comes back online, it's going to switch back to my preferred water source, automatically switching between my sources. I think where this comes in really valuable, especially in sustainability, is if we had a rain catchment that's small, it's going to drain out really quick. Well, so after an hour of use, it drops to the next, what's the next water source? Well, how many water sources can we do? Let's look at that again. There's 8 water sources, right? We could just rank these 1 through 8 if we want, or we could have 4 at the same time. We could do lots of different things with these. Okay, I think we got enough time for another. I was going to flip the script on this one. So imagine they use this for a season and they just have a rudimentary pump intake screen and they're putting algae and grit and all sorts of crap into the main lines. How do you think the irrigation crew is going to feel after cleaning out nozzles for the umpteenth time and valve sticking? They're like, no, we're kind of over this. They might want to flip back to the domestic meter, and maybe they want to use the domestic 1.5-inch meter as the primary source and the pump as the backup. Oh, okay, that's I could see that happening, but how about then water's going to get expensive? How about we limit how much water we go through the meter? Is that possible?
Yeah.
Okay. How do you think we're going to do that? Well, first what we got to do is we got to flip this. So let's go to, we're going to make this priority 1. So that's preferred, and the pump, let's go to priority 2. Okay. So now what we've got is priority 1, preferred water meter, priority 2, pump. So it will always use the water meter until it goes offline. Well, how are we going to take it offline? How about a water budget? So this could be a limit. We could say, let's say we want to avoid tier 2 or tier 3 water rates. We know this is nice and clean. Irrigation crew is going to like it. So we could put in 150,000 gallons in a month, in a 30-day month, and then shut down. And then save this. So let's come back and take a look and see what happens. Primary water source, we're using the 1.5-inch meter until we reach 150,000 gallons in a month. When it reaches 150, it closes the master valve here and automatically fires up the pump. So we could stay out of those tiered water rates using that. So we could
reset then every month, Dan?
Yeah, it's it's a 30. It is a 30-day month, so you might have to do some odd prorating for 28-day and 31-day months. But yes, it does reset. Yeah, so that's a way that you could kind of manage your cost. I think we take this assumption that everyone's going to want to use the lake water. Well, that's not always the case. Or maybe the pump's small. Maybe the pump's old and small and it doesn't do so well. Yeah. Cool. Okay, I think we had a couple questions. Let's take a look at that because I think we've got a few more things we could talk about, but I want to make sure we catch the questions. I like Ed's comment, and he goes, yeah, 20% is where he starts with, but so John asked a question. He goes, with the pump operating, wouldn't the 15 GPM unscheduled flow just bleed off the residual pressure in the main. Okay, so unscheduled flow, it could. So unscheduled flow is kind of funny, and I kind of glossed over that. Unscheduled flow is flow the controller doesn't know about. So do you want to allow, well, and we need to assume, this is assuming your main line is always pressurized, a normally open master valve or an always on pump or a VF, an on-demand pump. So if that's the case, unscheduled flow does make sense. Now, what kind of scenarios have you run into with unscheduled flow, or do you even address that, Tracy?
Yeah, typically it's, especially at athletic fields, you've got a lot of quick coupler use out on infields and those kinds of things. So you could have unscheduled flow with the quick coupler use. Just manual checks of things as sprinklers are being repaired and rotors are being fine tuned in. Somebody may just be manually bleeding a valve on and off if it's nearby.
Yeah, the good point. And unscheduled flow, it's such a personal thing, right? So in my training examples, I use 15 GPM as a threshold for quick couplers. But as soon as you manually bleed a 30 GPM rotor zone, the controller doesn't know about it. It's unscheduled flow, and it's going to either alert and shut down. I don't know. I'm always worried about I'm worried about customers getting too many alerts and just ignoring them. And then when the big alert comes through, it's just like, whoops, they missed that. They missed the mainline break. So I'd be worried about getting too many alerts, but that's something to work on. Frank had an interesting comment. Says we have strict air gap regulations. How do you, in other areas, how do you avoid cross contamination? So what he's talking about is, just so we can all see this, is we've got a pump station and a domestic meter all in the same system. Right. That needs to be addressed. And maybe my example isn't fully realistic. It's odd that in California, where I live, using a reduced pressure in assembly and RP is just, it's not almost as good. It's just one step below an air gap and depressurizing water. So that would be unacceptable with an RP that's tested annually in California. Local plumbing codes apply. I believe parts of Texas, if you're going to do that, you have to completely depressurize the city water, put it into a tank, have an air gap, and then repressurize it, which is just brutal.
Yeah, here in Colorado, we have to physically remove a section of pipe. Okay,
and that's what John
it's
added.
A spool piece or something. It's got to be completely air gapped and disconnected.
So for John and for you, my scenario probably wouldn't fly. Probably wouldn't work. Okay, and the other thing that wouldn't fly here in California is city domestic water and recycled reclaimed water. To mix those two together, they never want those. Right? There's that. You can't backflow if they're not connected, which was kind of so. Right, your local plumbing codes will ultimately apply on those. Awesome. I think we covered all the big things we wanted to cover. Something else that I think is worth mentioning and taking a peek at is season 1, episode 17, titled "Managing Peak Demand." Remember that one, Tracy? That was yours, actually. Yeah, that was yours. Yeah. What was that?
That was a city park in Westminster, where we had 3 3200s that are maxed out and a large main line, and we ended up hitting peak demand on the city's gray water system.
Right.
So that particular park runs 800,000 to 900,000 gallons a night when it's running in the summer, and so we ended up having to make some programming and priority adjustments to how those programs ran in that park, because that was a lot of water to get down in the water window. So from 7, I think it might have been 8 p.m. to 10 p.m. we could run 900 to 1,000 gallons per minute. But from 10 p.m. to 2 a.m. we had to back down the system to 500 gallons a minute.
Right.
And then from 10 a.m. to 8 a.m. or from 2 a.m. to 8 a.m. we could ramp back up to 900 gallons a minute. So during that peak demand from 10 p.m. to 2 a.m. we were taxing the system, and they were trying to deliver gray water to commercial customers.
Affectionately dubbed the triple bypass. So
Yes.
So worth watching. It dovetails into what we did here. Also want to point out on YouTube, I've got a couple of videos on single source water source setups and multiple water source setups. So there'll also be videos on YouTube. So we ran right up against our time. So Tracy, hey, thanks for joining us. We appreciate you.
Yeah, thanks for having me.
It's good to see you all. Hopefully we answered your questions and you got a training related topic. We'll hope to see you again real soon. Take care, everybody. Have a great week.
See you.
Bye.